All right, so this is for 6.2 using the law of cosines. There are two cases that we're going to go through and look at today. The first one is if we have all three sides. And then that's where we will go ahead and start. So we're going to go ahead and just start off. And I'm going to go ahead and tell you that the sides of the triangle are A is equal to 3, B is equal to 4, and C is equal to 6. I don't have any idea about the scale of this triangle. So all I know that, just remember when you set these up, A, the side of the triangle is always across it, B, and then finally C. That's one of the biggest mistakes that I see when I'm doing this. So this actually needs to be A6 because it's across from C. It does not matter at all which one I go through and which angle I find first. Let's just go through and find angle A to start with. So I go through and find angle A, so across from angle A is side 3, so that becomes 3 squared is equal to 4 squared plus 6 squared minus 2 times 4 times 6 times the cosine, let me move this out of our way, times the cosine of A. All right, now order of operations is really important here. So this is 9 is equal to 16 plus 36, 48 cosine of A. Now, the biggest mistake that I see is treating all of these numbers together, but they're not. That cosine is being attached and being multiplied times that 48. So the first thing you need to do is get all of this on one side of the equation. So that's going to give us 9 minus 16 minus 36 is equal to negative 48 cosine of A. Which goes ahead and gives us negative 43 is equal to minus negative 48 cosine A, or negative 43 over negative 48 is equal to the cosine of A. To find the measure of the angle value, remember that's just taking the inverse cosine of 43 over 48. So angle A is equal to 26.38 degrees. Now, at this point, if I was doing this or I was helping you do this in class, I wouldn't tell you to now go to the law of sines. Ratios are much easier to use. And now that I have the fact that this angle up here is 26.38 degrees, I have the opposite side. It's a much easier process to use ratios for this case. So to set up that ratio, all I need to do is say that the sine of 26.38 degrees over 3 is equal to the sine of B over 4. That will be one ratio. To solve for So sine of c over 6, and you can solve for both of those angles. The measure of angle B is going to be 36.34 degrees, and the measure of angle C is equal to 117.28 degrees. All right, we're going to do one more example using the law of cosines. And for this, we're going to use the case of the side angle side case. What I mean by side angle side in this case is I have triangle ABC where angle C is equal to 60 degrees. And I know that A is equal to 2 and B is equal to 3. All right, so if I go ahead and label this, this would be A, B, and C. I know C down here is 60. We can use this and solve this with exact values, but I want to show this example using the law of cosines. All right, so let's go ahead across from A, directly find where A is, go across, that is where 2, directly across from where B is 3. We want to go ahead and first find the length of side C. Remember, you cannot use the Pythagorean theorem with this because of the fact it's not a right triangle. Same thing, I can't use the cosine is equal to the opposite over the hypotenuse or anything because we don't have a hypotenuse of this triangle. So I go through and I know that C squared is equal to 2 squared plus 3 squared minus 2 times 3 times the cosine of 60 degrees. Solving that, I get that C squared is equal to 4 plus 9 minus 12. Now, remember that the cosine of 60 is just 1/2. So therefore, all of this is just equal to 7. So since C squared is equal to 7, C is equal to the square root of 7. So as I did in the previous example, you can go now and use the law of sines for this. However, I want to go through and give you a little bit more practice and show some examples using the law of cosines. But as I said before, there's no reason to use a law of cosines. The law of sines using ratios is definitely less cumbersome to use. But if we're going to go through and use the law of cosines, and to show you as an example, if I wanted to go ahead now and find the measure of angle A, I set that up as 2 squared. So I have 2 squared is equal to 3 squared plus the square root of 7 squared minus 2 times 3 times the square root of 7 times the cosine of A. All right, so now I'm left with 4 is equal to 9 plus 7 minus 6 square root of 7 cosine of A. I can't emphasize this enough. It is really important to treat all of this as one term and move that 9 and that 7 over first. So what I have is 4 minus 9 minus 7 is equal to negative 6 square root of 7 cosine of A, which gives us negative 12 is equal to negative 6 square root of 7 times cosine of A. Let me just pick this up to give us a little bit more room. So I have negative 12 over negative 6 square root of 7 is equal to the cosine of A. And remember, to find the measure of that angle, what I do, I take the arc cosine of 12 over 6 square root of 7, or the 0.755928. Now, the easiest way to put this into your calculator is just to go through and calculate that first, and then go through and put in the cosine of negative 1. In your calculator, hit the second button and then the answer, and it will go ahead and give you the fact that the angle A is equal to 40.9 degrees. All right, so we already have angle A and C. We have all the sides of this triangle. The only thing that we need left is to find the measure of angle B. You can get that by subtracting all of those angles from 180 degrees. And you get that angle B is 79.1 degrees. If you really want a little bit more practice using the law of cosines, how you would set this up would just be 3 squared is equal to 2 squared plus the square root of 7 squared minus 2 times 2 times the square root of 7 times the cosine of B. You're going to get that the cosine of B is equal to, cosine of B is just equal to 2 over 4 square root of 7, or the cosine of B is equal to 0.18898. Same answer either way. You're going to end right back up with a measure of angle B. I strongly recommend that you practice putting all of these numbers in the calculator and making sure you're getting the same answers. It can be a little tricky, so please make sure that you have all of them and can use the calculator correctly for your test.